Hello class, we're about to start section 1.2 notes, estimation graphs and mathematical models. Our objectives. Number 1, use estimation techniques to arrive at an approximate answer to a problem. Number 2, apply estimation techniques to information given by graphs. And number 3, develop mathematical models that estimate relationships between variables. Now we come here to estimation. Estimation is the process of arriving at an approximate answer to a question is called estimation. Estimates are not meant to give exact values for answers, but are a means of determining whether your answer is reasonable. We often round numbers to estimate or approximate an answer. For example, if you're given the time and say it's actually 2:59 p.m., most people would say 3 o'clock. They estimate it. And finally, the symbol, these squiggly equal signs here, means is approximately equal to. Now, we have our methods of estimation. We have rounding numbers, using graphs, and using mathematical models. Now, with rounding whole numbers, we look at the digit to the right of the digit where rounding is to occur. If the digit to the right is 5 or greater, add 1 to the digit to be rounded. Replace all digits to the right with zeros. If the digit to the right is less than 5, do not change the digit to be rounded. Replace all digits to the right with zeros. It says note, rounding can be applied to decimal notation, used to denote part of a whole. We round the decimal part of a decimal number in nearly the same way that we round whole numbers. The only difference is that we drop the digits to the right of the rounding place, rather than replacing these digits with 0. And you also must remember the symbol, this symbol here, means it's approximately equal to. Now we come to our first example. It says round the world population. This is 6,751,593,103. Now we want to round this to the millions place. So the first thing we need to do is look at our place value at the millions place. This 1 here is in the millions place. So what we would need to do is go to the right of this 1 to the digit right next to it, which is 5. And according to the earlier definition, since this is 5, that means we would add 1 to this 1, and all 6 of these digits behind this number here will become 0. So this would be 6,752,000,000, and then all the rest are zeros. Now we come here. It says to the nearest thousand. So here, I'm going to use some different ink here. Here we go to the thousands place. This 3 here is in the thousands place. So we look to the right of this 3. The number to the right of this 3 is 1, which is less than 5. So that means we leave the thousands place the same, and all the digits behind it become zeros. So it'll be 6,751,593,000. Now it says to the nearest billion. So we look here. This 6 is in the billions place. So we look to the right of this 6 and we have 7. We know 7 is 5 or greater, so we will add 1 to this 6, and the rest of these 9 digits will become zeros. So it'll be 7 billion. Now it says here to the nearest 100 million. So we look here at the 100 millions place. The 100 millions place is this 7. So we look to the right of this 7, which we have a 5. And we know when it's 5 or greater, we will add 1 to this place value. So it'll be 6,800,000,000, because all the rest of the digits behind the 100 millions will become zeros. Now finally, it says here to the nearest 10,000. So we need to determine the number that's in the 10,000s place. The 9 is in the 10,000s place. So we look to the right of the 9. We have a 3. That's less than 5, so the 9 remains the same. Everything behind it becomes zeros. So it'll be 751,590,000. And that is our final answer. Now let's scroll down to the next example. It says here, the first 7 digits of pi are 3.141592. And it says round pi. It says here to the nearest hundredths. So we go behind the decimal and we look for the hundredths place. So we have tenths, hundredths. So we know 4 is in the hundredths place. So we look to the right of this 4, and to the right of this 4 we have 1, which means this 4 stays the same. But instead of making all the digits behind the 4 0, all of those drop off. So this will become 3.14. Now it says to the nearest thousands. So we go here, the thousands place is this 1 here. We look to the right of the 1 and we have a 5. So we know when it's 5 or greater, we will add 1 to this place value, and then all 3 of these digits will drop off. So it'll be 3.142. Now we go to the nearest tenth. Now the 10th place is this 1. We look to the right of this 1 and we have 4. That's less than 5. So the 1 stays the same and all of these digits behind it drops. So it'll be 3.1. Now it says to the nearest 10,000s. So we'll go here and we will find the 10,000s place. The 10,000s place is actually this 5 here. So we look to the right of the 5. We look to the right of the 5, it's a 9, so that's 5 or greater, so we add 1 to the 5, and we will add 3.1416, and drop everything behind the 5, which is the 9 too. And we're done with this example. Now we scroll down to the next example. It says estimation by rounding. You purchase bread for $2.59, detergent for $2.17, a sandwich for $3.65, and an apple for 47 cents, and coffee for $5.79. The total bill was $18.67. Is this amount reasonable? So, to check, what place value seems appropriate to use to round each cost? So, now what I would suggest that we do is this here. If we were actually at the grocery store, typically when we have dollar amounts like this, to make it easy for us, we will round to the nearest dollar. So we would take this $2.59 and round it to $3. So again, we would take this $2.59 and we would round this to $3. We would take this $2.17 and we would round that to $2. We would take this $3.65 and we would round that to $4. We would take this 47 cents and we could just basically round that to $0, because we know in order to round up, this will have to at least be 50 cents. So then next, we would take this $5.79, we would round that to $6. Now, when we add all of this up, this equals $15. Now, when we compare $15 to $18.67, that seems quite high. But if you added all of these together, the original amount is $14.67. So this is very, very close. So it asks the question, is this amount reasonable? We would say no. Okay, now we want to go to our next example. It says estimation by rounding. Sandy Mendez decides to purchase bagels for her colleagues. Estimate her cost if she purchases 29 bagels at $1.99 each. What place value seems appropriate to use to round the cost? Okay, now, if you look at $1.99, you know when you're shopping it'll be easy to go up to $2. But the place value we're looking at is we're looking at the first place value behind the decimal, which is 9, because we're going to round to these dollars here. So we would look at this 9. 9 is 5 or greater, so we would add 1 to this 1, and that would give us $2. So we'll take our 29 bagels times $2. So 29 times 2, we know would give us $58. And that will be the final answer. And we know this $58 is within about possibly 29 cents of the actual value. So that's very close. Now, we come here to the example, estimation by rounding. A carpenter who works 4 times earns $28 per hour. Estimate the carpenter's weekly salary. Now, what we must do is this here. Remember, it says estimate the carpenter's weekly salary. First of all, we know the average American to be full-time works 40 hours in 1 week. Now, we really don't need to put the 1 here, but we could just put that here for right now. So we work 40 hours in 1 week. And we're going to multiply that by how much the carpenter makes an hour. Now, to make this a little easier, why not round to the tens place? So the place value we're trying to round is the tens place. We look to the right of this 2. This is 8. So we know we would add 1 here. And this would be approximately $30. Okay, so now we would have that the carpenter makes approximately $30 per 1 hour. Now, if you notice here, we can simplify out hours and hour. And now we multiply 40 times 30 is $1,200. And a week times 1 will give us a week. So it'll be $1,200 per week. So it should be written as this here. It should be approximately $1,200. Now we scroll down here. It says estimate the carpenter's annual salary. Now, one thing you all need to know is this here. Depending on what you're dealing with, as far as banks or a literal year, that would determine if you would use 52 weeks or 50 weeks. For this example here, we're going to basically use 50 weeks. Okay, so we look here. First of all, we determine that the carpenter made $1,200 a week, approximately. Now we're going to multiply that by 50 weeks. And that's for a year. Now, let me go over here and give a little bit more explanation. Remember, it's 52 weeks in a year. And since we're doing approximation, we're still round to the tens, which is this 5. We look to the right of it, it's a 2. So that means that the 5 remains and we will have 50. So this is how we come up with the 50 weeks. Now we multiply 1,200 times 50 will give us $60,000. $60,000. Now, weeks and weeks will simplify out, and that will leave us year. So it'll be $60,000 a year. So it'll be approximately $60,000 in 1 year. That is the approximate salary. Now we come to our next example. It says using estimation and calculations. The Martellos traveled 1,276 miles from their home in Springfield, Missouri to Yellowstone National Park.